So one last derivation, very simple derivation. Now intrinsic carrier concentration. So an intrinsic semiconductor is one where you are not applying any doping. You're not creating any kind of impurity in order to increase the conductivity. It is just a pure semiconductor. So for a pure semiconductor, this is the electron density we saw, this is the hole density we saw. Now Ni is the number of charge carriers, meaning the number of particles which are capable of conducting electricity. Now in a pure semiconductor, what are the particles which are capable of conducting? Electrons as well as holes, both are capable of conducting electricity. So number of intrinsic charge carriers is equal to number of electrons is equal to number of holes. Ni equals N equals P, because it is actually an electron hole pair which leads to conduction. So you need to have one electron and one hole, that is when electricity is conducted. One or more of course, but you need electrons as well as holes in order for electricity to be conducted by a semiconductor. So the number of charge carriers is equal to N is equal to P. It is not N plus P, it is Ni equals N equals P, because we are talking about the number of electron hole pairs. So Ni square is equal to N squared or P squared or Np, because they are same. So we want to find an expression for Ni. So first we take Ni squared, which is Np, which is a product of these two. You take Nc, Nv, and then you combine all the e power terms. Both EFs get cancelled. Nc, Nv, e to the power minus Ec minus Ev upon Kt. Ec minus Ev, we just saw it is equal to Eg. So Nc, Nv, e to the power minus Eg upon Kt. This is Ni squared. So Ni is going to be root of this, which is root of Nc, Nv, e to the power minus Eg upon 2 Kt. Why do we have 2 here? Because the e to the power term also gets a root, and it is just to the power 1 by 2, so the 2 comes to the denominator. So you replace Nc and Nv with the respective constants, you apply the square root, this is the final expression you will get. So what did we do here? Intrinsic charge carrier is the number of bodies which are responsible for conductivity in a semiconductor, in a pure semiconductor. In a semiconductor, an electron hole pair is responsible for conduction. So the number of intrinsic charge carriers is equal to the number of electrons is equal to the number of holes. So to find Ni, we first squared it. Ni squared equals Np. We took the product of these two expressions, we combined whatever could be combined. We got this Ec minus Ev, we replaced it by Eg. Now we got this expression for Ni squared. Ultimately what we want is Ni, so we just take the square root. So final expression for the number of charge carriers in a semiconductor is this.